Good day, everyone. Welcome to another video discussion in physics about motion graph, in particular, distance versus time graph. Now, when we make distance versus time graph, always remember that we will need to use two axes. First is the x-axis, which time always runs on it. Second is the y-axis, which is intended for distance. So vertically, that vertical line is your y-axis, and that horizontal line is your x-axis, represented by d and t respectively. Now, our first example of distance versus time graph is showing constant speed. So a constant speed, the slope of an object moving at constant speed is diagonal straight. Now here is a task. You are supposed to use a dashed line that show a second object with a slower constant speed. And the answer is okay. So that dashed line shows or indicates a slower constant speed. Now, why is the dashed line moving slower compared to that of the green line? So imagine, of course, that this moving object is taking time to go for a certain distance. And look at that green line. It took little time moving from the starting point, which is from the center, going up to a certain distance. While the dash line, the blue dash line, takes longer time moving from the starting point, that is the common point, moving to a certain distance. So it took longer time for the dash line to move to the same distance as the green line. Now, another scenario here, in the distance versus time graph, draw the slope of an object that speeds up. And what do you call this motion? And our answer here is okay. So that curved line going up means right, it's moving in different speeds. Basically, it speeds up. It's getting faster and faster. And what do you call this motion? Yes, change in speed is remarkably known as acceleration per unit, or the change of speed per unit of time. Okay, another scenario here. Now draw the slope of an object that's getting slower. And what do you call this motion? Earlier, we are given that scenario, the slope of the object that gets faster. Now, what about the slope of the object that's getting slower? Okay, the slope of the object getting slower is also a curved line. However, it's bent towards the x-axis, or it's bent towards the time component. Unlike in the acceleration where it's getting faster, you see it is bent toward the d component. Okay, so which suggests this one will have lesser time compared to this slope that's getting slower. That means it covers more time as it bends towards the x-axis. And what do you call this object that is getting slower? Okay, correct. It is called deceleration, or also known as negative acceleration. So to make this one clear, what's the difference between deceleration and acceleration? Your deceleration is the motion of an object that's getting slower over time. As you can see in the graph, it is bending towards the x-axis, or it's bending towards time. That means it covers more time compared to the motion of the object that is speeding up or getting faster. It is bending upward. So it covers less time, but more on distance. It covers more distance with lesser time. So that is the difference between acceleration and deceleration slope. Okay, next one. Show the slope of an object moving at constant speed, but this time it goes back to its starting point. So we know already that constant speed means diagonal straight line, but this time it is going back to its starting point. And our answer here is okay, that's correct. So it starts with a certain distance marked by d there, or the y-axis. Then it goes back towards it goes back towards the starting point, and the starting point is the zero point, the intersection between the x and the y-axis. So that means it is going back to its starting point when it is going towards zero. Now, show the slope of an object moving back to its starting point but getting slower. So here it is, we are asked to give the slope of a moving object back to its starting point but not moving at constant speed. Instead, it is getting slower. So our slope here is a curved line going back to starting point, or going back to zero position. And that is it. That is our slope. So it's not a diagonal straight line, but it's a curved line. That means it is moving back to its starting point, but getting slower. Another, the slope of the object that is going back to its starting point, but speeding up. Okay, so take note. Earlier, we are asked to make the slope of an object back to its starting point, but getting slower. Here, we are asked to make a slope of an object that goes back to its starting point but speeds up. And you're correct. That is the slope of the object moving back to its starting point but speeding up or accelerating. Okay, next. Try to draw a speed graph that shows an object that is at rest or that stopped. And our slope here is, okay, take note, as time goes by, the distance didn't change. It remained as is. It remained at rest. It is not moving. Otherwise, we could have seen that distance changes in a certain period of time. But in this example, as time goes on, the distance remain constant. That means it is not moving. Okay, here's the next challenge. Interpret the speed graph based on the following. So you have here first a diagonal straight line, then a flat horizontal line, and then back to diagonal straight line. So what do you think will be the meaning behind this slope, or the slope of your motion graph? Okay, so here you're going to describe how fast the object is probably moving as it travels along the line from left to right. Now it started slowly because of its diagonal straight line, slowly but moving at constant speed. Next, as it approached towards the flat horizontal line, it means the object stopped moving, or the object is at rest. And as it approached towards a steeper diagonal line, it means it is now moving faster than the previous one. So the first one, moving slowly but at constant speed, when it reached the flat line, that means it is at rest for a certain period of time. So more or less around, that's 10 to 15 seconds. So he is at rest for, or the object is at rest for 5 seconds. And it starts moving But this time, since the slope is steeper, it means it's moving at constant speed but at a faster rate. Okay, so other way of realizing why or how why it moves slow or how it moves fast. Now we can just imagine to put a ball on the slope. So this ball will roll slowly when the slope is not steep, but the ball roll faster when the slope is steeper, and the ball will stop moving if it's flat horizontal line. Okay, I hope that helps you in understanding or analyzing how it moves fast or how the motion of an object will be using an imaginary ball that you will place into its slope. Okay, and always remember that steep lines on motion graph mean an object is moving quickly. Non-steep lines means the object is moving slowly. Now this time we'll integrate these three these three slopes. One, the object that travels constant speed, then slows down, then comes to stop. So constant speed first, and then it decelerates, it slows down, and then comes to stop. So what will be the motion graph of the following? And here is our answer. Okay, so for constant speed, diagonal straight line. For deceleration, when it is slows down, it is bending towards bending, favoring time. Okay, bending towards time. And when it stops, that means horizontal flat line. Okay, another example here. Try drawing a speed graph that shows an object that accelerates, then decelerates, comes to stop, and then move backward at a constant speed. So one is it accelerate, second it decelerate, third it comes to stop, and fourth it goes back to its starting point but at constant speed. You might be saying, sir, it's so many to figure out that graph. It's quite complicated. No, it's not actually complicated. We have to do it one at a time. Okay, and the answer here is okay, so first it accelerate, meaning to say it's getting faster. So the curved line or the slope should be a curved line bending towards distance. Okay, and then it decelerate. So the slope bends or curve towards time. Okay, so that's acceleration, then deceleration. Next is come to stop. So it's a flat horizontal line. And lastly, it goes backward or it goes back to its starting point at a constant speed. So the slope is diagonal straight all the way down to the starting point at zero position. Okay, here's another example of different motion graph. Okay, so you have your green line that means fast and steady speed. You have your blue line, curved blue line that means getting faster. And then you have a diagonal red line that means steady or constant speed, and then the flat horizontal line is stationary, and then going back to its starting point, that means it moving at constant speed but it goes back to the zero position, that means touching the x-axis. Okay, that is all for today. Thank you so much for your participation, for listening, and for watching this video. And always remember, keep going, keep growing. King Huan Learnings, embrace learning.